The next thing I would recommend is putting out all your hardware. You don't have to be so neat about it like I am right here, but it really does help to take all your pieces and figure out what they're going to be used for. For instance, when I was putting the center pivot on, I used one of these washers, but it was until I put all of the hardware out that I realized there was one larger washer and it needed to be used there. So this would probably be for the lower panhard replacement that's not going to be empty. And then you can start to figure out where everything's going to be used. It would be easy when you're in the middle of a build to grab a piece of hardware and not understand, like, are you missing something? It doesn't seem like it's going to go together. So once you realize you only have 4 of these, you can see that they're for this. Also, the instructions kind of give you some measurements that you can use a caliper to figure out what hardware goes with what. Now the instructions say just to remove this driver's side sway bar link, but you're actually going to get a lot more room in this short time if you swing this thing down. That's going to afford you room to work on this bit right here. Should be that. So with this spacer in place, basically gonna thread this guy in here, then torque that to the specified amount. One thing I'm doing differently than the instructions as well is actually putting these axle clamps brackets on before you put in the Watts link frame. They have you obviously putting this in, then putting the pivot on, and then putting these brackets on, but I figured might as well put them in now while I have all this extra space. I put this sway bar up, attaching one of the end links over here. This one's still out of the way for when I put the frame in. But one thing I'm kind of glad I did start to put this in beforehand is there's not a lot of space for this bolt to go in from this angle. So you'll see that the nut's actually kind of right up against it. Once it's going to be tightened, the nut's going to be here, the bolt's still pretty far. There isn't enough space to actually, at this location, put the bolt in going through that direction. So kind of got to fiddle with this around. As you can tell, before you have everything tight, you're going to want to do that. So with it loose like this, kind of gives you the opportunity to work on it easier. So you're going to want to snug this bracket up. You're not going to want to fully tighten it, but the bracket needs to be all the way against this spring perch. Then in order for it to remain kind of vertically positioned, you're going to want to get at least one of these top bolts and one of these bottom bolts snugged up. So I have a 9/16 inch open end wrench, and this is actually an impact ratchet. Then do the same for the bottom. So basically you want to stop when it feels like the gap at the bottom of the bracket and the gap at the top of the bracket is the same, but you can still move it around. So this one is, you know, quite similar. I guess it's a little easier because it naturally wants to fall down instead of you having to hold it up. But you run into the same issue. You actually can't install these bolts through here because of this bracket, so they all have to go down. Also, what's different about this bracket is you have, not sure if you can see it, but there's a notch there. There's a notch in the top of the bracket for this kind of air bleeder. That's for the differential. You're going to snug this all the way over to the side, and then in the same deal, snug up the middle ones with an equal gap between the two brackets. One thing I should mention about this is the top of the bracket is actually the short end. You want to make sure you put the short end of this axle clamp bracket facing up. So let's see if we can get this Watts link brace started. I'm kind of just pivoting this thing up right now. Alright, what's that? So this is the issue I've run into. Put both of these spacers in here, they're relatively loose. Put the nuts and washers on here. So this is definitely in the right location right here. This won't really move side to side. But then, these holes don't line up. Let's see if having the end link in here to sandwich makes a difference. You gotta kind of squeeze the frame. That one goes in well. So this is where things get a little tricky. This is a magnetic angle finder. What you would prefer to do, best case scenario, is, I'm not sure if you can see that, but you'd want to put this on the face of the plate. Measure that angle, then, not necessarily measure it off of that, but once you have this on, measure it off of that. But as you can see, maybe you can't, there's no real place to put this. I mean, you can actually kind of get it in there, but you're not getting a very accurate reading because you got washers here in the sway bar. So what we need to do is measure it off the back of here. So looks like I got 92.6. Then, keeping your orientation the same, you can't go off the face of this, you actually have to go off the back of this. And you're going to want that same 92.6. Now stick with me here because this isn't going to be the end of it. 92.876. So, that's actually not the reading you're going to use. Since you want to use it off the face of this, you have to figure out what your final angle reading is, which 87.5. So in order to be right off of this flat surface, the face of this needs to be 87.5, which means the face of this needs to be 87.5. So at this point, assuming these are perfect, I mean, this won't change, but this can move back and forth now, it doesn't really matter. Once we put this on, we need an 87.5, and then we know we're golden. And actually, if you do the perfect math, the inverse is 87.4. So now we have the full weight of the rear of the car on the differential, which simulates ride height somewhat. You did that with the jack. Now the ride height or the frame rails are just a hair above the jack stands right now, and that's in case anything lets go, it falls on the jack stands. But for now, you need to simulate the ride height, which is pushing the differential into the car. And that way, once you figure out the orientation of these arms, you can set these brackets on here to match. So what I did is I clamped the rotor in a more or less vertical position, because I'm assuming at ride height, when these arms are parallel, that the rotor is going to be vertical. Then I stuck my angle finder on the bottom of this bracket and found it was about 178.8 degrees, which is like 1.2 degrees inverse from 180. So I'm going to try to match that, kind of have this mocked up to figure out what hole I'm going to use. So I plop this on here, and then kind of just visually line up the holes and see what holes I'm going to be using. Now this is going to depend on the ride height of your car, because if your springs are much longer, this bracket's going to be pushed down. If your springs are much shorter with the lower car, this bracket's going to be pushed up. That's why you put it at a simulated ride height. So with these holes lined up visually, I'm at about 178.6. Yeah. 178.6, 178.7, and I was looking for 178.8, and that's at the second hole from the bottom. If I were to go to the last hole, I'm at 179.9, and if I go from the third hole up, 174.5, 175. So the second hole up looks like it's going to be a winner. Let's snug these brackets up. Now, since putting weight on the axle here, it's possible that the Watts link arm could have changed angle based on loading. So we got 93.2. So you're going to want something like 86.8, which is the inverse of that on this bracket. 86.8. Right there. .8. So now you're going to snug up all those bolts and maintain that angle reading. Now that this is stable, you can always finish tightening the bolts to torque. Once this is lowered, it'll allow you more room, but you should be able to get this relatively stable without moving. You can adjust the length of these linkages so that it can line up with the linkage hole. Now once it's on the ground, you can adjust this so that you can augment the axle orientation of the car, but for now you just want to line it up so you can get the bolts through. Looks like you're actually going to have to drop this sway bar in order to get this bolt through. It's kind of lame actually. I actually had to take my clamp off of this center pivot in order to drop the sway bar. And now with this linkage at this length, it should keep this pivot mount roughly vertical for the other side's use. So this is a bit of a headache. Basically you need to get a wrench socket some sort drive tool on this nut. And then you also need to brace it from this side, so either hold it with a wrench and wrench on here or vice versa. But because of this gap, you can only really get maybe an open end wrench on there, or possibly an adjustable wrench if you're lucky. Maybe not. But that leaves you this much space to fasten this. Not a lot of room. So you can either do it really slowly with a 3/4 inch open end wrench, assuming you have 2 of them, or maybe a ratcheting box end if you have one, which is pretty rare. This side is a little bit easier because you have the space of approach, which means you can get the close end on this and socket here. But another issue is this bolt. As you can see, it kind of wants to run into this frame as it is. You have some room to push it in, but that's because I'm at the second hole up. If you were at this bottom hole, this bolt actually wouldn't be able to slide through here with this bracket still on. So you're going to need to, at least on any of the bottom holes, likely tighten this up to this bracket before you tighten these, which makes things a little bit difficult because, one, you haven't set your final angle for this bracket yet because you're planning on doing it off of this right here. And then also because this bracket doesn't look like it's going flush here, so once you tighten these down, this whole thing's going to want to kink that way, which will make it even harder to try to put this bushing in after you've tightened it to this bracket.